major part of mathematics, and differentiation is the nothing but rate of change. Rate of change of point. Now the differentiation here. Okay. Differentiation is the rate of change or slope of a function, and it is simple terms we say how quantity changes respect to another. In mathematical uses to derivatives of function often representing velocity, slope, growth and rate. Then key points of the differentiation is in instantaneous state of change, and 17th century it's developed, and it is focused by motion and physics in Newton from England, and modern calculus is built up on their combined contributions. Applications in the field of engineering, circuit analysis, optimization, motion, signal analysis, and in civil engineering, stress strain analysis, slope calculation, and traffic modeling. Next, differentiation is nothing but a rate of change. Already we know. First, in this straight line is a constant gradient. Then on any curved graph, the gradient is always changing. Its value depends on where you are along the x-axis. Here, the curved line is gradient changes. That is a tangent line of a curved line. Next, we see about the general rule of differentiation. For a constant and the variable. So f of x, we consider a function f of x equal to a into x power n. Here, then the derivative. So the first derivative of f of x is denoted by f dash of x. The general rule for a into x power n is f dash of x is equal to n into a x power n minus 1. This is our general rule. Let's see the example. Find the derivative of a function of each the following. First one, f of x is equal to x cube. Here n equal to 3. F of x is equal to x power 3. In our general rule, we get x power 3. So n equal to 3. So f dash of x is equal to n into x power n minus 1. n is 3 and x power 3 minus 1 is 2. So f dash of x is 3x square. Next example, f of x is equal to 2x square. Here a is 2. A constant term a is 2 and 2 x square. So n is also a number 2. So n into, so 2 into a is 2, so 2 into 2 4 and x power 2 minus 1 is 1. So we get f dash of x is equal to 4 into x power 1. Next example, f of x is equal to x power minus 2. Minus 2. Here n value is minus 2. So you get x power n minus 1. So minus 2 minus 1 you get x power minus 3. So minus 2. So n value, so x power n, f of x is equal to x power n, then we get f dash of x is equal to 2 into x power minus 3. So here minus 2, so minus 2 into x power minus 3. In the fourth example, f of x is equal to minus 3 into x power minus 3. Here a value is 3 and n value is minus 3. So a into n. So you get minus 3 into minus 3, minus into minus plus. So 9, 3 into 3, 9. So 9 into x power minus 3 minus 1, you get minus 4. So 9 into x power minus 4. Next one. F of x is equal to 1 by x square. 1 by x square can be written as x power minus 2. So x power minus 2. Now our power n equal to minus 2. So minus 2 f of x power f of x is equal to x power minus 2. So you get minus 2 into x power minus 2 minus 1. So you get minus 2 x power minus 3. Next example, f of x is equal to square root of x. So square root of x can be written as square root of x can be written as x power 1 by 2. Then 1 by 2 into x power minus 1 by 2. 1 by 2 minus 1. Here n into x power n minus 1. Here n is n 1 by 2. So 1 by 2 minus 1, you get minus 1 by 2. So 1 by 2 into x power minus 1 by 2. X power minus 1 by 2 can be written as 1 divided by square root of x. Already you have a x. So square root of x and 1 by 2 into square root of x. Next we work out the gradient of a curve at a particular point. This is when differentiating is used. Here for example, here x is equal to 3 is a particular point. We substitute into f of x is equal to x square. First we take f of x is equal to x square as given. Then we find f dash of x. Here n equal to 2 and we know the general rule f of x is equal to x power n. Then f dash of x is equal to n into x power n minus 1. So 2 into x power 2 minus 1 is 1. So you get 2x. Next we substitute x equal to 3. So x equal to 3, then you get 2 into 3 is 6. So f dash of 3 is 6. Next one, calculate the gradient of a curvature. F of x is equal to x square and the coordinate minus 2, 4. So minus 2, 4. Here the coordinate points minus 2, 4. X is equal to minus 2 and y equal to 4. So given that f of x is equal to x square and x is equal to minus 2, we substitute x equal to minus 2. A particular point x equal to minus 2. Next we have to find f dash of x. Already we know x square. The first derivative of x square is 2x. Then we get f dash of x is equal to 2x. Next we substitute the value of x is equal to minus 2. Then you get 2 into minus 2, we get minus 4. Next example, find dy by dx, that is the first derivative of x when y equals x square minus 6x minus 4. Now we work out the first derivative in polynomials. Polynomials, what is meant by polynomial? A constant with the variable. It's called polynomial. When the polynomial which is equal to 0 is called equation. Here we solve the polynomial x square minus 6x minus 4. So y equal to x square minus 6x minus 4. Then we find the first derivative of y. So you get dy by dx is equal to x square minus 6x minus 4. So differentiate each term separately. So a number on its own disappears. So we get x square, the first term x square, first derivative of x square is 2x and minus 6x. The first derivative of minus 6x is minus 6 and the constant term of the first derivative is 0. So we get minus 2x minus 6. Then next example, then find dy by dx when y equals 3 minus 5x square. Now we solve the polynomial 3 minus 5x square. We already know the constant term of differentiation is first derivative of a constant term is 0. So when we solve the first derivative of the constant term 3 is 0 and the second term minus 5 is a variable. So minus 5, then we write x square term. X square, first derivative of x square is 2 into x power 2 minus 1. So 5 into 2 we get 10, already here minus, so minus 10 into x. Next example, f of x is equal to 4x square minus 8x plus 3. Find the gradient of the curve y equal to f of x at the point 1 by 2 comma 0. Here what is the value of x? X value is 1 by 2. Then f of x is equal to y. So we write y equal to 4x square minus 8x plus 3. Then the derivative of y, it can be written as dy by dx. Then 4x square, 4 is the constant, so 4 into x square. So x square, the first derivative of x square is 2x. So 2 into 4, 8x minus 8. So the constant term. Differentiation of x term is 1 plus the differentiation of constant term is 0. Okay. Next we substitute the value x is equal to 1 by 2. So f dash of 1 by 2 which is equal to 8 into, instead of x we substitute 1 by 2. So 8 into 1 by 2 we get 4 minus 8. So we get minus 4. So the f dash of 1 by 2 which is equal to minus 4. Next example, find the coordinates when the graph y equal to 2x square minus 5x plus 3 has a gradient of 7. So y equal to 2x square minus 5x plus 3. Next we find the derivative. So 2, the constant term 2, write 2, then x square. What is the value of first derivative of x square is 2x. So 2 into 2, 4 minus 5. Differentiation of x is 1 and differentiation of 3 is 0. So we get f dash of x is 4x minus 5. Here they give the gradient is 7 at the point we want. So the gradient value is 7. So 7 equal to 4x minus 3. Then we get here minus 5 can be changed into plus 5. So 7 plus 5 equal to 12 equal to 4x. Then x is equal to 12 divided by 4. We get 3. So x value is 3. Okay. Next step, we substitute the x value in the polynomial. So 2 into x square. Instead of x, we substitute 3. So 2 into 3 square is 9 minus 5 into 3 is 15 plus 3. So we get y equal to 6. So we get the point 3 comma 6. So the graph has the gradient of 7 at 3 comma 6 point. Next example, find the gradient of the curve y equal to x square, where it meets the line y equal to 4x minus 3. set the equation is equal to each other. So x square, y equal to x square, here y equal to 4x minus 3. So we substitute y instead of x square, we get x square equal to 4x minus 3. Then we rewrite the equation x square minus 4x plus 3 equal to 0. Remember, when the polynomial which equal to 0 is called an equation. Next, factorize this equation. You get x minus 3 and x minus 1 equal to 0. Then x minus 3 equal to 0, you get x equal to 3. And x minus 1 equal to 0, you get x equal to 1. So you get differentiate x square, y equal to x square to get a gradient function, y equal to x square. Then dy by dx is equal to 2 into x. So at 1, 1 point the gradient will be 2. Next example, x cube into 3x minus 1. Next we rewrite the equation, rewrite the polynomial x cube into 3x. So you get 3 into x power 4 minus 3x cube. So you get the differentiate the first derivative of 3x power 4 is 3 into 4 into x power minus 4 minus 1, you get 3. Then 3 into x power 3 minus 1 is 2. So 12x cube minus 3x square. Then we factorize this, we get 3x square into 4x minus 1. Next we differentiate 1 divided by square root of x. So you get square root of x can be written as minus 1 by 2. Then minus 1 by 2 into x power minus 1 by 2 minus 1. So minus 1 by 2 minus 1, you get minus 3 by 2. So we get minus 1 by 2 into x power minus 3 by 2. So we get x power minus 3 by 2 can be written as x power 3 into 1 by 2. Already we know x power 1 by 2 is the square root of x. So x cube, so square root of x cube. So minus 1 divided by 2 into square root of x cube. Next we differentiate x minus 2 into x square. So split into two fractions. X divided by x square minus 2 divided by x square. Then x can cancel, then you get 1 by x minus 2x square. The next step, we rewrite the equation. So we get x power minus 1 minus 2 into x power minus 2. Then the polynomial dy by dx, which is equal to minus x square minus 2 into minus 2, you get plus 4, minus of minus plus 2 into 2, 4 into x power minus 2 minus 1, which is minus 3. So you get dy by dx is equal to x power minus 2 can be written as 1 divided by x square plus 4 divided by x cube. Then 1 divided by x square plus 4 divided by x cube. The x square can be written as x divided by x cube. Multiply and divide by x, so we get x divided by x cube plus 4 divided by x cube, which is equal to minus x plus 4 divided by x cube, with the denominators common. Okay. Next, f of x is an original equation, then f dash of x is the first derivative, then f double dash is the second derivative of the function. Now we find the first derivative and second derivative of the following. D square y by dx square is the second derivative of the function y, and dy by dx is the first derivative of the function x, and it is denoted by f dash of x and f double dash of x also. So y equal to 3 x power 5 plus 4 divided by x square. So f of x is equal to 3 x power 5 plus 4 divided by x square. Then f dash of x can be written as 5 into 3 is 15 x power 4 plus 4 into minus 2 is minus 8 and x power minus 2 minus 1 is minus 3. Next we have to find f double dash of x, which is equal to 15 into 4 16 x power 4 minus 1 is 3 plus minus 8 into minus 3 we get 24 minus of minus plus 24 into x power minus 4. Next find dy by dx and d square y by dx. Next example is 3 into square root of x plus 1 by 2x. So you get f of x is equal to y can be written as f of x because x and f is a function from x to y. When it is on 1 and on 2 condition satisfies, we write f of x is equal to y. So f of x is equal to 3 into square root of x plus 1 divided by 2x. It can be written as 3 into x power 1 by 2 plus 1 divided by x power minus 1. 1 by x can be written as x power minus 1 and square root of x can be written as x power 1 by 2. Then the first derivative f dash of x is equal to 1 by 2 into 3 is 3 by 2 into x power minus 1 by 2 plus minus 1 into 1 by 2 you get minus 1 by 2 into x power minus 1 you get minus 2. Then f double dash of x is equal to minus 3 by 4 into x power minus 3 by 2 plus x power minus 3. Next term, this is a curve. Next, the tangent curve, the tangent line. The tangent is a straight line that intersects the curve at the point 1. The normal is a straight line which is perpendicular to the tangent, which is perpendicular to the tangent where it touches the curve like this. This is the normal. Next one. Find the equation of the tangent curve. Y equal to x square minus x cube minus 3x square plus 2x minus 1 at the point 3, 5. So we need the gradient of the tangent. So the curve at the point given x equal to 3 and y equal to 5 because the point 3, 5 x equal to 3 and y equal to 5. So the given equation is y equal to x cube minus 3x square plus 2x minus 1. When we first differentiate the y, we get dy by dx. It can be written as dy by dx. Then 3x cube. The first derivative of 3x cube is 3x square minus x square differentiation is 2x. So 3 into 2, 6x plus 2. The first derivative of x is 1 and first derivative of constant is 0. Second one, then we substitute the value f of x. So x equal to 3, the point we substitute in ax. So f of 3 equal to, instead of x we substitute 3. So x into 3 the square minus 6 into 3 plus 2. So f of 3 equal to 3 square is 9, 9 into 3 minus 6 into 3 plus 2, we get 11. Next we use the straight line formula. Already you know the formula, y minus y1 which is equal to m into x minus x1. We substitute the values of y1 and x1. So y1, you know the given 3, 5. So we substitute x is equal to 3 and y1 equal to 5. So you get y minus 5 equal to 11x minus 33. Then you get y equal to 11x minus 28. So the curve and the tangent. So next example, 8 minus 3 2x. Then you get 8 minus 3 into square root of x can be written as x power 1 by 2. Then we differentiate. We get minus 3 by 2 x power minus 1 by 2. 8 is a constant, so it can be 0. And rewrite the equation of of x is equal to minus 3 by 2 into x power 1 by 2 can be written as square root of x. So minus, so we write denominator in root of x and we substitute x equal to 4. So instead of x we substitute 4. The point. So f of 4 equal to minus 3 by 4. The gradient of the normal curve. By 3. So 8 minus root 3. Already make a 8 minus 3 into square root of x and x equal to 4. You get y equal to 2. The coordinates at the intersection is 4, 2. Then you get the straight line y minus y1 into m into x minus x1. You substitute y1 as 2 and x1 as 4. So we get 3y minus 6 equal to 4 into x minus 4. And you get 3y minus 6. 4x minus 16. Then get the answer. 3y minus 4x plus 10 equal to 0. This is our simple notations. Check this. Formulas of gradients